car A, whose mass is 1,340, travels east at 21 meters per second. Car B travels north, right? So we have it set up. Find the resultant velocities. We have a mass with velocity going to the right. We have a mass with velocity going to the left. We have to determine where the final velocity, which will be at an angle. So we need to break these into components, right? So we know how to do this with components. We find our x and y components. This one has an all x component, no y component, right?
Mm-hmm.
This one has an all y component, no x component, right? So all we have to do to determine this is use, find this momentum, which is a vector quantity, find this, and then we use our trig, have a right triangle. And so this was all our x component is this guy before. We have the masses stuck together. And we're looking for the x component after. So we divide this entire momentum by the mass of both cars. We have our y momentum. We take the mass of both cars to find our y velocity afterwards, final y, final x, and then we just set it in there, right? C squared is equal to a squared plus b squared, right? Yeah, okay, piece of cake.
Did you
And then I use a tan,
Did you do tan?
inverse tan, opposite over adjacent. 11 divided by 8, inverse tan, gives you the angle, right? Yeah. All right, so the last one, second to last one. All right, now we have cars colliding that are at an angle with each other. This one's still only on the x-axis. That one is at an angle to our coordinate system. They collide into each other. We have a momentum of this car, which is at an angle 63 degrees to our x coordinate. We have a car that's straight on our x coordinate. So the first thing we do is we find our, they're going to stick together. We find our x coordinate because that's the easiest one, right? Because this is, or actually a y coordinate. This one has no y coordinate in here. All right, so what we have going on here is this is the mass of two cars stuck together. We're looking for the x coordinate of our final velocity, and then we're going to find the y coordinate. So this car is all x coordinate. So we have a car with a mass of 1,900 kilograms and a speed of, or velocity of 12 meters per second. Negative, right? It's going to the left. It's negative. So we have minus 1,900 times 12. And then we break this to find just the x component. It's still, mass is scalar, so we use the sole mass. We don't use a component of mass. So we use just, we have our, I do here, x and y. So our x is the cosine. So our Vx of car A is equal to the cosine 63 degrees, or cosine theta, of our V, which is 22 meters per second. So this is our mass, which is scalar, so we use the whole mass, and this component of our velocity, which is the x, and this times the cosine of 63 minus the mass times the velocity. Divide this side by 3,400, cancel that out. Divide this side by 3,400, and now what we have is we have the Vx final after our collision.
Why wouldn't we find the
Y?
yeah instead? Because that would make a right triangle.
We're going to find the Y. We have to find, to make a right triangle, we still have to find both sides, right?
Yeah.
So we start with the X. All right, so we have the VX. Now we can find the VY. And then we do a right triangle. All right? So you got that?
No.
2.3 meters per second to the left, or negative 2.3 meters per second to the right. Yeah? Going on? And then we find the next component here. Oops. Yeah, okay, it's good. So now what we're going to do is we're going to find the Y component. All right, so we have 1,500 kilograms, 22 meters per second, gives you the Y component is the sine, X was cosine, Y component is sine. We have our after collision to find this Vy is 3,400, right?
What happened to the other cars? Why isn't that in there?
There's no Y component for the other car.
Oh, that's right.
That's why I told you it was easy to find the Y component, because you only have a Y component of this one. Now, obviously, there's the components, the two components add up. So this car, the X component, had more pull in the last problem than this one. So there's our answer for that. Now, we want to find out what our, we have 2.3 to the left. We have 8.65 south, or to the bottom. And we're looking for our hypotenuse, for our resultant. C squared equals A squared plus B squared. Inverse tan, opposite over adjacent. All right, we'll take a quick look at this. We have car A with mass of 1,260 kilograms goes east. Car B with mass of 1,630 kilograms goes 30 degrees north of east. Vehicles collide and couple, and skid marks are 44 meters long. We see that here. At 18 degrees north of east. Coefficient of friction, sliding friction, is 0.8. Find the initial velocity of A and B, both cars A and B. So we got to put in all our information. We have a car going due east that has a mass of 1,260 kilograms. We have a car that's traveling 30 degrees north of east with a mass of 1,630 kilograms. When they smash into each other, their skid marks are 44 meters long, and they're at 18 degrees off of east, north of east. And our kinetic coefficient of friction is 0.8. We're looking for the velocity of A initially and the velocity of B initially, and even the velocity afterwards. All right, so we do free body diagrams of a couple cars. We have one car going east. We have the weight or force of gravity is mass times gravity, acceleration due to gravity. So we have a mass of 2,890 times 9.81 meters per second squared. Gives us a force of gravity or weight of 28,351 newtons. And our normal force is equal and opposite to our weight in this situation. So our normal force is also equal to 28,351 newtons. Our kinetic friction for this car is our coefficient of kinetic friction, or for the mass of the two cars together, is 0.8 times our normal force, and that gives us our frictional force of 22,681 newtons. So that we know that our work is equal to our kinetic energy. Our work is the force applied over a distance. Our distance was 44 meters. The force that worked was the force of friction, stopping the car. So our work friction did equals the velocity change from a velocity, which we don't know yet, to 0, or to rest. So we have a initial velocity we're going to look for, and the final velocity is 0, and we have the mass of the two cars stuck together. So 1/2 mv squared. All right. We know this side. We know our frictional force. We know our distance, 44 meters. All right. So times 2, divide by 2,890, then square root it, and we get 26.3 meters per second at 18 degrees. This initial velocity is in the north of east, so it's positive, the positive quadrant. So now we know what the speed of the car is, the two cars stuck together after, so we know our final momentum is mass times velocity. We need to find our initial momentums. And we could break this into our x and y components. So we have our initial y is the sine of our 30 degrees off this car. This is initial, this is final. So the sine of 18 degrees is the two cars stuck together and a speed of 26.3 meters per second at 18 degrees. So we find our y component after the collision. We find our y component before. This car A is only in x direction, so it doesn't have a y component. The sine of 0 is 0. X is in the 0 degrees. We have our B component over here is the sine of the 30 degrees off the eastern horizon. And that's the mass of the car. So we found our initial velocity of car B. And to find the x component, both cars have an x component. We have the cosine of 26.3 with the two cars stuck together, the mass of the two cars. So we have a velocity for car B, and the cosine of 30 degrees of that velocity gives us the x component of car B times the mass of car B, plus, this is our momentum of car B, plus, or our x momentum of car B, plus our x momentum of car A, which happens to be traveling in the x direction, so it is 100% of its x momentum. And we solve out the algebra, and our answer is 25.1 meters per second. So we multiply this times all of this, we subtract this from here, and then we divide that whole answer by 1,260, and we get 25.1 meters per second in the positive direction. All right, piece of cake. Have a good one.